Here we have a problem on logarithm. That is, we have to prove the given equation. That is stuff we have on the left side. That is log base 3 of 8 divided by log base 9 of 16 times log base 4 of 10 equals to 3 times log base 10 of 2. Okay, now what I'm going to do is I'm going to take the stuff on the left side and prove that this is equal to the stuff on the right side. Okay, now let me write the stuff on the left side as it is. It is log base 3 of 8 divided by log base 9 of 16 times log base 4 of 10. Okay, now let me keep this one as it is. It is log base 3 of 8. Now I move this logarithm, that is log base 9 of 16 to the numerator. Okay, whenever I move a logarithm from numerator to denominator or denominator to numerator, what I have to do is I have to switch the base and argument. So when I move this logarithm to numerator, this argument 16 will become base and the base 9 will become argument times log this base 9 will become the argument and this 16 will become the base times the same thing. When I move this logarithm to numerator, I have to switch the base and argument. Then I'm getting a log base 10 of 4. Okay, here when I consider stuff on the right side, there is only single logarithm with base 10. So if I want to get the stuff on the left side that is equal to the right side, I have to get this complete stuff as single logarithm with base 10. Okay, let me consider the logarithm over here and logarithm over here. So the base is 3 here, the base is 16, and for this one we don't have any trouble because already we have the base 10. So now to get this stuff equal to the stuff on the right side over here, I must be getting base 10 for all the logarithms in this expression. Okay, so how can I get base 10 for these two logarithms over here? For that, we can use the concept change of base. What is change of base? Let me consider the concept, that is, let me write it, log base b of a. Now, in this logarithm, the base is b. I just want to change the base of this logarithm b to some other base, for example, say c. Okay, if I want to change the base b to base c, what I have to do is I have to write two logarithms in a fraction. Okay, now for the logarithm in numerator, whatever argument we have over here, the same argument should be taken as argument for the logarithm in numerator, and the base over here should be taken as argument for the logarithm in denominator. Now, whatever base you want, you can take for both the logarithms over here in numerator and denominator, but you must take the same base for the logarithms in numerator and denominator. As we are going to have base c, we have to take base c for this one and this one. That is, we have to take same base. Not only c, even if you want some other base d, we can take it a base d, but the condition is we have to take the same base for both the logarithms in numerator and denominator. Okay, if I want to get base 10, so I have to take base 10 over here, base 10 over here. Okay, now we can use this concept over here in this logarithm to get the base 10, because my aim is to get base 10 for all the logarithms over here, so that I'll be able to get this expression equal to 3 times log base 10 of 2. And we don't have to do anything for this one because for this one already we have the base 10. Okay, now what I'm going to do is to change the base 3 to base 10 in this logarithm. I have to write two logarithms in a fraction, log over log, and for the logarithm in numerator we have to take this 8 as an argument, and for the logarithm in denominator we have to take this base 3 as the argument. And now whatever base I want, I can take for both the logarithms over here, but the base must be same. Let me take base 10 for both the logarithms over here. So the same thing I can do over here, that is log 9 divided by log 16. That is, I have taken this argument 9 as the argument for the logarithm in numerator, and this base 16 is taken as argument for the logarithm in denominator. Now I can take base 10 for both the logarithms times log 4 to the base 10. Okay, now look at each logarithm over here. Each logarithm is having base 10. Okay, now we can do some simplification over here. For that, what I'm going to do is log base 10 of this 8 can be written as 2 to the third power because it's a power of 2 divided by log base 10 of 3 times log base 10 of this 9 is a power of 3. We can write as 3 square divided by log base 10 of this 16 is a power of 2. It can be written as 2 to the fourth power times log base 10 of this 4 is a power of 2. It can be written as 2 square. Okay, now let me erase the stuff we have over here and continue the problem. Okay, now what we can do is we can use the power rule of logarithm. What is power rule of logarithm? Actually, the argument of a logarithm is a power. Whenever the argument of a logarithm is power, the exponent we have at the argument can be moved in front of the logarithm and it has to be multiplied by the logarithm. So the exponent 3 is, if 3 is moved in front of this logarithm, then I'm getting 3 times log base 10 of 2 divided by log base 10 of 3 times. So the same power rule can be used over here. There is this exponent 2 can be moved in front of logarithm. Then I'm getting 2 times log base 10 of 3 divided by here the same thing again. There is 4 times log base 10 of 2, and so here also the power of logarithm can be used. Then we get 2 times log base 10 of 2. Here we can cancel this log base 10 of 2, log base 10 of 2, and log base 10 of 3, log base 10 of 3. 2 goes into 2 one times, and here 2 goes into 4 2 times, and this 2 can be cancelled. Finally, we are getting 3 times log base 10 of 2. So this is the stuff exactly we have on the right side of the given equation. Okay, here I have taken the stuff on the left side of the equation. I have proved the stuff on the left side is equal to the stuff on the right side. That is 3 times log base 10 of 2.